Okay, so let's do this problem. First, we want to identify what kind of problem we're looking at. The first thing that stands out to me just by like glancing over this is this 99% confidence interval. That means that this is a chapter 8 problem. We're looking at interval estimation. I can also see that we have proportions, right? We have this 75%. So that means this is a proportions problem and it's a chapter 8 problem. So let's just take a look right here. This is the cheat sheet. This is the proportions part. And we're doing interval estimation. So these are the values that we're going to be needing. We're going to need our p-bar, we're going to need our critical value, our standard error, our margin of error to get our upper and lower limits. The good thing about these problems is like this chapter or these this exam is that these problems guide you through getting the answer. So it's really not that difficult. So to get our margin of error, for example, we need our critical value and standard error. So that's like where this comes in, but it has you calculate the SE and the CV first. So it's like you need these two to get to this. So this kind of guides you through it. But let's get started. Let's write out the things that are given to us in this problem. So in a pool of 500 graduate students, so 500 is our N. So let's do N equals 500. We have a p-bar right here of 0.75. Let's write that down as well. And we have an alpha. So our alpha is going to be 0.01. So alpha is 0.01. And the way you get alpha is you do 1 minus. So you do 1 minus the confidence level. So when you do this, you're going to get 0.01. And that's your alpha. Okay. So this, I didn't mean to cross that off, but this and this are the same. Okay. All right, so let's get our standard error. What's the formula for standard error? If we go back to here, we can see our standard error formula is the square root of p-bar times 1 minus p-bar divided by n. So what I'm actually going to do is I'm going to switch to Excel just so that you guys can see how I would do this and on Excel. I think that will help. So give me 1 second as I switch over. Okay, so we are trying to get our standard error, and we said the formula is the square root of p-bar times 1 minus p-bar divided by n. What I would like us to do is calculate the 1 minus p-bar to the side, because this is going to make our formula a lot easier. So I'll explain it once we get to it a little bit more clearly, but here we go. So let's do 1 minus p-bar. Okay, so that's 0.25. Okay, so now let's do the standard error formula. So if you guys remember, it's you do equals square root of p-bar. So I'm going to do p-bar times 1 minus p-bar. So because we already calculated this to the side right here, we don't have to do that one, the parentheses 1 minus, that can get kind of tricky, especially when you have a lot of parentheses. You might forget one, it might mess up your answer. So I think this is the best way to do it. So we're just going to say 1 minus p-bar, we already calculated that here. So we just do this and we can divide it by n. There we go. So there is our standard of error. So it's going to be 0.019. Just to show you guys how you could do this if you weren't to do this step, it would be equal square root. It'd be p-bar, right, times 1 minus p-bar. So now we'd have to do open parentheses 1 minus p-bar. And then you have to close the parentheses, put another parentheses divided by n, right? It's like that's kind of a big formula. This compared to this, right? Like this one is a little bit, this one's a little bit nicer. But you can do whichever way works for you. Anyways, so that's our standard of error. So we can, let me stop sharing. Let's go back to this. All right, so we got 0.019, so there's our answer. Now we need our critical value. How do we get our critical value? So let's go here. Our critical value for proportions is z of alpha divided by 2. What is z of alpha divided by 2? That is your norm dot s dot inverse 1 minus alpha divided by 2. So that's how you're going to get your critical value. So it'd be equals norm dot s dot inverse 1 minus our alpha is 0.01 divided by 2. So let's actually go to Excel and do that. Okay, so our critical value, we said it's norm dot s dot inverse 1 minus our alpha divided by 2. And when we do that, we get it's going to be 2.58 if you round that. So let's go back here. All right, so 2.58, there's our answer. Now to get the confidence interval estimate, let's just take a look right here. That's going to be these two, so plus or minus. So our p bar plus and minus our margin of error. How do we get our margin of error? That's the critical value times the standard of error. So critical value times the standard of error, what we just calculated in these two, is going to give us our margin of error. So that means we need to multiply 0.019 times 2.58 to do this. And we're going to be adding and subtracting from p bar. So what is our p bar? Our p bar is 0.75. So 0.75 plus or minus this. Let's go to Excel to get the margin of error. So I'm going to stop sharing and go back to Excel. Okay, so we said our margin of error is going to be our standard of error times our critical value. So standard error times critical value, and there we go. So that's going to be 0.04988. In other words, let's just round that to 0.05. Okay, so let's switch back. All right, so I just wrote down what we got, 0.04988. So it's going to be our p bar 0.75 plus or minus 0.05. So that matches with this answer choice. So that would be our answer. The next question is asking, suppose around the period the above poll was conducted, the dean of the university made a statement saying that 85% of graduate students only used internet for assessment purposes. And they want to know if we reject or do not reject. So what this is asking is 85%, does this lie within this range? So let's see if it does. I think it's very easy to see this through Excel. So let's go back to Excel. So let's determine what our upper and lower limits are to determine if we're trying to determine if 85%, so 0.85, lies within this range. So lower limit and upper limit. So the way that we calculate our lower limit and upper limit, we said that's going to be our P bar. Lower limit is going to be minus our margin of error. Our upper limit is going to be P bar plus our margin of error. So we can see that 0.85 does not lie within this range, right? 0.85 is above the upper limit. So that means that we reject the claim. So I'm going to go back here. So we can reject the Dean's claim. A. This next question is asking us to find the sample size. We are looking for n. The formula for calculating sample size when dealing with proportions is this. This is a big formula, right? It looks kind of scary, but it's honestly not that bad. So let me just try to break this down a little bit. This z of alpha divided by 2 is the same thing as your critical value, right? The z of alpha divided by 2 is this. That's your critical value. This p times 1 minus p, that's something that we calculated within our standard error, but that's not too bad. The ME, which is margin of error, that is something that is given to us in the problem. Okay, so I guess the way that I would look at or try to write this problem out is I would say it's like your critical value squared times p times 1 minus p divided by your margin of error. The margin of error here is 10%. Okay, so it's going to look something like this, 0.10 divided by, what's your critical value? Your critical value is, where is that? Here. That's your 2.58. So we're going to be squaring that, and then multiply by p times 1 minus p. So that's going to be 0.75 times 0.25, right? That's p times 1 minus p. And we're going to get an answer. So let's actually take a look at what that looks like in Excel. Let me stop sharing. Let's go back to Excel. Okay, so here we go. So we are trying to get our sample size n. We said that formula is our critical value squared. What I'm going to do is I'm going to do this in sections so that I make sure I don't mess up on the parentheses and mess up on all of that, because I think it's very easy to make that mistake. And you know what? Something that I just realized I made a mistake on. Let's actually go back. Let me actually address this. Just like you want to be careful when doing these problems, is that your margin of error, so once this loads, your margin of error, as shown in the formula, needs to be squared. So it needs to be margin of error squared, right? So this needs to be squared. Okay, now let's go back to Excel and we can do this last problem. All right. Okay. So we are solving for n. Let's do our margin of error squared first. So we said our margin of error is 0.1 squared. All right, so that's that. We need our critical value squared. That's a part of the problem. So critical value squared. And we need our P times 1 minus P. But we can just, I think, solve the problem at this point, just do it in full. So let's just do our N. So it's going to be equals, parentheses, the critical value squared, which is this value, times our P times 1 minus P, which we calculated here, all divided by our ME squared, and we get that. And let me just do that right there. Okay, so we get 124.4. We're always going to round up. If it's 124.7 or 124.4, 124.1, we're always going to round up for the purposes of this. So we're going to say it's 125. That's going to be our answer. So stop share. Let's go back to here. So the answer would be C, 125.